My next example is on adding polynomials. Polynomial number 1 is negative 3x cubed plus 2x minus 4. I want to add this to 4x cubed plus 3x squared plus 2. This will work very similarly to collecting like terms. I'm going to drop those parentheses because really the only thing that they do is outline that I have polynomial number 1 and polynomial number 2. If I'm connecting this with a plus sign, the parentheses don't do anything. So I'll just drop those. What I have is I have a positive x to the power of 3 and a negative x to the power of 3. So I'm going to put those two together. I have 3x squared, so that's left alone. I have a 2x that's left alone. And then I have a negative 4, which can be put together with a positive 2. I will do this in ascending order, so my polynomial, the final answer for the polynomial question is in the order that I want this in. Negative 3x cubed plus a positive 4x cubed, that's a positive x to the power of 3. Then I have my positive 3x squared. The next one is a positive 2x. And to follow this up is negative 4 plus 2, which is a negative 2. Let's try to do this one more time. I'm trying to add 4n cubed plus 4n minus 5 with negative n cubed plus 7n squared minus 2. This is my first polynomial, this is my second polynomial. I want to open those parentheses, maybe with one additional step. Positive, negative, that's just a negative here. This is a plus 7n squared minus 2. Collecting like terms, the x cubes will go together. I have my n squared, I have my n, and I have my numbers that I can put together. So 4n cubed minus n cubed, that's 3n cubed. Then I have my positive 7n squared. Then I have the positive 4n, and then the negative 7. If you have multivariable polynomials, the addition will work very similarly. You need to collect like terms. In this case, I have 13x cubed y plus 3x squared y minus 5y that I want to add with x cubed y, positive 4x squared y, and negative 3xy. Sometimes what people find convenient is to do a vertical addition. So if you have your 13x cubed y, and then you notice that there's another one of this here, you'll write it right underneath. My next term is 3x squared y. I have my 4x squared y here to match. On top here I have a negative 5y on the bottom. On the other side I have a negative 3xy, so maybe I'll leave some space and write it over here. So if I'm adding these polynomials this way, I'm only writing like terms right underneath each other. So I have a 13x cubed y's plus 1 of those x cubed of the same x cubed y's. So together I have 14x cubed y's. My next term is x squared y. I have 3 of those from the first polynomial and 4 more of exactly the same thing from the second, so I have a positive 7x squared y. I have the negative y and the negative y xy. Because this is a degree 2 term, I'll write this first, and then I'll write that one last. Although if you switch the order, it's not that big of a deal either. Right after addition comes subtraction. Subtracting polynomials just require one more step in opening those parentheses. So if I start out with negative 3x squared plus 4xy minus 2x squared minus 5xy plus 7y squared, you have this negative that needs to be distributed through the parentheses. And that is how you subtract polynomials. You keep the first as is, and then the second polynomial gets negated all the way through. So you end up with a negative 2x squared. Negative times a negative is a positive 5xy. And negative times a positive is a negative 7y squared. You collect like terms in a similar fashion. So the x squares are put together with x squares, xy together with xy, and the y squared is all by itself. So negative 3x squared and another negative 2x squared, you end up with a negative 5x squared. A 4xy plus another 5xy, that's a positive 9xy. And then you have your negative 7y squared. Let's try to do this one more time. 3x to the power of 4 minus 2x cubed plus 6x minus 1 minus 3x to the power of 4 minus 9x cubed minus x squared plus 7. You keep the first polynomial as is, and then negate everybody else. You have a negative 3x to the power of 4, negative, negative, you have a positive 9x cubed, negative, negative, positive x squared, and then the negative, positive, negative 7. What would be convenient would be if I take this second polynomial and try to match this. Notice 3x cubed and a negative, no, 3x to the power of 4 minus 3x to the power of 4, those will cancel each other out. Negative 2x cubed plus 9x cubed, you have a 7x cubed. Now this is a 6x and this is an x squared, so this doesn't exactly match. So you have both of these, a positive x squared and a positive 6x. And then you have your negative 1 minus 7, which is a negative 8. And there's your answer for this particular subtraction problem. This is it for section 5.1. And let me finish this.